So we're gonna, in 4.3, we're gonna now move on and start talking about the significance of f double prime, right? So far in sections 1, 2, 3, we're talking about the significance of f prime. We find the derivative, we do the number line, and then when f prime is positive, that's the slope, the graph is increasing. When f prime is increasing, when f prime is negative, it's decreasing. So that's f prime. Now we're going to tie in f double prime, because when you find f double prime, where it's positive and negative also has an implication on how the graph looks, okay? All right, so take a look at the graph here. This is the graph of some f of x, all right? But you can see that the graph has critical points, several critical points, but it does not necessarily have maxima or minima at every single critical point, okay? So for example, take a look at here, this point here, f prime, which is slope, is 0. It's for an instant over there, the graph is horizontal, like it's constant. So the slope is a horizontal line. There is 0 slope, right? So f prime is 0 there, but there is no extrema there. So where do extrema happen? Take a look at this point. Here, the graph changes from increasing to decreasing, right? So that's a maximum. At this point, at C3, the graph changes from decreasing to increasing. So that's a minimum. So at C1, even though that's a critical point, the graph does not change from increasing to decreasing. It's increasing before and it's increasing later. So there is no extrema. Okay? The same thing here. F prime is 0, that's a critical point, but there is no max or min there because it continues from decreasing to decreasing. So do you see that? So it's not necessary that there is a maximum or a minimum at every critical point. Okay? All right.
And the critical point is when it equals 0.
Yes,
or
when it's undefined. So for example, take a look at this C4. Over here, the slope is not 0, but the slope is undefined. Okay, so this is an example where f prime is undefined. Okay, there is an absolute max there though. All right, so the key is that the sign of f prime should switch, right? So like f prime should go from positive to negative at the critical point. That's when you have a maximum or a minimum. Okay. All right, so that brings us to the first derivative test for local extrema, okay? At a critical point, if f prime changes sign from positive to negative, then there is a local maximum. So here are two examples. This is the critical point C. To the left of it, f prime is positive. To the left of it, to the right of it, f prime is negative. Okay, that means it goes from increasing to decreasing, so there is a local maximum. Same thing with here. This is the critical point C. To the left, f prime is positive. To the right, f prime is negative, so there is a local maximum. Okay, what's the difference between the two? In the one case, we have a critical point because the derivative is 0. In the other case, we have a critical point because the derivative is undefined. F prime is undefined. Okay? All right, so take a look at case number 2. If f prime changes from negative to positive, then there is a local minimum. Again, we have one situation where you have a critical point where f prime is 0. One situation where you have a critical point where f prime is undefined. Yeah.
So whenever it comes to like a point kind of that's undefined, but when it's like a rounded one, it's not.
Right, that's when it's 0. F prime is 0, correct. So take a look here. This is the critical point C. To the left of it, it's minus. To the right of it, f prime is positive. So there is a local minimum. Here too, to the left of it, f prime is negative and then positive, so there is a minimum. So basically, if this is C, right? And if this is f prime, if C is the critical point, if the sign for f prime is minus then plus, it goes from increasing to decreasing, decreasing to increasing, so there is a minimum. All right? Here, if this is the critical point and this is f prime, if it's plus and minus, it changes from increasing to decreasing, there is a maximum. So that's the first derivative test, to see if there is a local extrema at the critical point. So if at the critical point, the sign for f prime changes between plus and minus, there is an extremum. Yeah.
Where does the f prime c equals 0 or f prime c equals defined? Where does that come into the, is that just a part of the picture?
Well, remember how critical points happen in two ways. You can get critical points where it's 0 or, so these are two pictures. One picture is like, this is a picture where f prime is 0 here, because there is a horizontal tangent. This is where the derivative is undefined because there is a corner. Now, if you have a critical point, these are both critical points. If you have a critical point, but the sign to the left and the right is the same, then there is no extremum. So take a look here. F prime is positive and f prime is positive, no change, no min or max. F prime is negative, f prime is negative, no change, no max or min. You guys get it? Okay. Now, how about if we're looking at an end point? Okay? How about if we're looking at an end point? So, suppose you have an end point, you know, and the end point is A. So, for example, like if you're given an interval, right? A comma something, okay? At that end point A, okay? Suppose here, this is f prime. Suppose it's negative here, right? What's happening? If f prime is negative, what's happening to the graph? It's decreasing. That means at A, it was at a high point, so that's a maximum. Okay? Now let's take a look again at this example. Suppose again you have a boundary like this. This is the end point, A. And this is f prime. Suppose the sign of f prime is positive here. If it's positive, what's happening to the graph? Increasing, so here you have a minimum because it's increasing from a low point. Okay? Now, how about at a right end point? So suppose like you have an interval something comma b. So here is b. If immediately before b, the f prime is negative, it's decreasing. That means is b a minimum or a maximum? It's a minimum because it's decreasing to that minimum value b. Okay? And similarly, if you have b, but this is f prime is positive, it's increasing, so here you have a maximum. Right? It's a little bit conceptual, but fun. I like this stuff. Yeah, right? It's like, yeah, it's like the perfect amount of like conceptualizing. Yeah.
How is that increasing? That last one.
If suppose like this is the endpoint B and immediately before it f prime is positive. If f prime is positive, that means the graph is increasing. So it's increasing to a high point here. So that last point here is a maximum. Like the graph is increasing to a maximum value.
So it's increasing from left to right?
Mm-hmm.
Okay.
Yes, yeah, it's always left to right.
Okay.
It's like English, not Hebrew, always.
Oh,
Okay.
That makes so much more sense.
Yes.
Flipping right to left.
Graphs are always left to right.
Great.
Okay, so let's use the first derivative test to determine, local extreme values. All right. Now, so first, remember, we should take a look at domain. the domain here is negative infinity to infinity. And we do that just to make sure all of the critical points that we find are within an accepted domain. Right. Well, both, but you should know at this point that all polynomial functions, so something like this, have a domain of all reals. Okay? All right. So f prime of x is going to be 3x squared minus 12. So when I set f prime of x equal to 0, right, I'm going to say 3x squared minus 12 equals 0. 3 times x squared minus 4 equal to 0. 3 times x minus 2, x plus 2 equal to 0. That's the fun algebra 1 / algebra 2 part. So x equals plus or minus 2 are our critical points. Okay? All right, so, huh?
Those things, I always want them. Does it equal 0 or does the 3 just like go away?
The 3, you can divide it out.
Okay.
And since you can divide, since it's a constant which you can divide out, it makes no relevance on the zeros. Okay, so now we want to see whether -2 and +2 will qualify as minima or maxima. And they will qualify as minima or maxima if at each point there is a change in sign. Okay? So, remember we were going to do our little helper there and put f prime. So we know now we're going to plug numbers into f prime. So from the leftmost region, let's say I take -3. When I plug it into f prime, does that give me a negative or a positive answer? Positive answer. And then let's say I put in 0, I get negative. And suppose I put in like a 3, I get positive. Right? So if f prime is positive, the slope is positive, the graph is increasing. You see how I reasoned that out? If f prime is negative, the slope is negative, so the graph is decreasing. If f prime is positive, the slope is positive, so the graph is increasing. Notice also that in all of those sentences, never once did I use a pronoun. When you start using pronouns, it is positive, it is increasing, things get messy because you don't know if it refers to f prime or f. So I always say if f prime is positive, then the graph is increasing, then f is increasing. Be specific so you don't confuse yourself. All right, so here we have a max and here we have a min. So we have a max. And these are, local extreme values, so we're not specifying absolute. Okay. Max is f of -2 equals how much? What do we plug it into now?
The normal.
To the f of x, right? To the function. Good. And that'll give us, I'll tell you, 11.
Makes sense,
Okay.
because you're not finding the slope.
Exactly. You're finding the value of the actual function. So f of 2 is -21. All right. And, I tell my own children this when they're doing math problems. Once you get your answer, ask yourself, what question do you ask yourself? Does the answer make sense? Does the answer make sense? Does it make sense that the maximum is a value of 11 and the minimum is a value of -21? It does. Like when you have that mixed up, you know you did something wrong. Okay? All right.
How is this problem different from the ones we did the other day?
It's not. We're just explicitly applying the first derivative test. So we're just learning, and it is exactly that. Now we have a name to it. It's exactly what we did before. Now we have a name to it.
So for the quiz, we're not technically learning the whole new lesson.
Right.
Okay.
Right. But now you might have like some complications where like it won't be like minus plus minus plus. You could get like minus minus plus. In that case, if it's minus minus, you know there is no minimum or maximum there.
Okay.
Okay.
So when that is the case, do you just write,
Well, you just don't even, you ignore it.
Right? If it was going minus plus,
Right.
then there'd be one answer.
Correct.
Okay.
Okay, now, what's the difference between A and B? What's the difference in the type of problem between A and B?
B as in second one has log.
One's just like a straight.
What else is the difference?
There's a range.
There is an interval. There is an interval. When there is an interval, you have to remember to check endpoints. Okay? All right. Now, this is another type. So we have to take a derivative. How are we going to take a derivative? Product rule. This is a product rule.
Oh.
This is definitely product rule. So this is U. This is V. So why don't we just write it up? U is x squared minus 3. V is e to the x. U prime is 2x. V prime is e to the x.
Yes.
Okay? So, f prime of x is u prime. So when you write it like this, the benefit of writing it like this is I just do like a crisscross, right? So it's u prime v, because the derivative of e to the x is e to the x, plus x squared minus 3 e to the x, right? So now can I factor out an e to the x? Not only can I, but I should. So that's what I get. Okay? And we like to write our polynomial functions in order of decreasing exponents. Like this. So now we're good. Let's see if we can factor that guy. I think so too. So x plus 3, x minus 2. Now, x minus 1. Now, we want to set f prime of x equal to 0. So it's going to be 0 equals e to the x, x plus 3, x minus 1. Okay, from x plus 3, I get that x equals negative 3. From x minus 1, I get that x equals 1. What about e to the x? What is the value of x for which e to the x equals 0? There's no value. There is no value.
I think you just cancel it out.
Well, you don't cancel it. You leave it there. It's just never equal to 0. Okay? So
Same as if it wasn't a 3.
e to the x never equals 0.
Does that matter?
It does, because like you can't get any values from it. You just know that like you can't get any values from that.
No, because it.
So now these are our critical points. Are they both within the domain that we're given? They are. So now let's put them all here. So here we have negative 5 and 5. And here I have negative 3 and 1. Okay? So in the so again, this is f prime. In the region between negative 3 and negative 5, so like at negative 4.
What about anything before negative 5? You don't do,
Right? So in the first region, when you plug it in, we're going to get positive. And then in the second region, like let's say we pick 0, we're going to get negative, and then positive. Okay? So increase, decrease, increase. So there is a max here. There is a min here. Now, here's where the first derivative test comes into play. Look at what we said here. When you have an endpoint, right, a left endpoint, and immediately after it's positive, there is a minimum here. So here, there is a minimum, and here, there is a maximum.
Wait, what was the rule again?
Okay, so remember what we talked about here. If you have a left endpoint A, and immediately after it, it's positive, if f prime is positive, that means the graph is increasing from a low point, so there is a minimum here.
Is the reason we didn't do it on the problem before is because it was negative infinity to infinity?
Correct. Now, we are not looking for absolute min or max here. We're looking for local min or max. That means we have to include all of the, like all of the relative min or max. So where do we have minima? We have minima at f of negative 5 and f of 1. We have maxima at f of negative 3 and f of 5. And the values here At f of negative 5, it's 22 e to the negative 5, which is 22 over e to the 5. And in calculus, it's totally fine to leave it that way. Now, f of 1, if I plug 1 into this, right? 1 squared minus 3 is negative 2. E to the 1, it's negative 2e. Do you see how simple it is? Like, you don't even need to plug into your calculator. So what if I plug negative 3 into that highlighted function? Negative 3 squared is 9. Minus 3 is 6. E to the negative 3, that's 6 over e cubed. Isn't that fun? And then we have f of 5. What if I put 5 in there? 5 squared, 25, minus 3, 22, e to the 5.
That's our answer?
That's this entire thing is your answer here. It is actually.
We're gonna get to the quiz. Why is it taking so much longer? It's because we're gonna actually have to be the ones that are putting it in the front and looking at it. So funny, guys. I'm serious though, because right now we're just really funny. Once you give us the answers and we prove it.
That is not as simple as it sounds. That's physics. Yeah.
Just to like 100% confirm, because I can't get this.
Concavity. Here we go. Concavity. So, when you look at a graph, until now, you've only ever been taught to see whether a graph is increasing or decreasing. You've never really been taught to look at other features of a graph. Okay? Now, when you have a graph that looks like this, okay? Or let's do this. Suppose you have a graph that looks like this. This is a parabola. Okay? Look at how there is a difference in the way this parabola looks on the left versus on the right. On the left, it looks, well, let me continue this. Look, on the left here, on the left here, look at the blue part. This looks like a right side up cup, right? Or a container. And then if I continue with the red, this is an upside down container. Is that correct? Okay. When it looks like the blue, it's a right side up trophy. We call it concave up. The opposite is called concave down. And this concept is called the concavity. All right? So let's take a look at some of the different situations that could happen. Okay? This is a graph that's increasing. This is a graph that's increasing. In the first case, this is increasing, but it's concave down. In the second case, it's increasing, but it's concave up. Okay? Take a look here. Decreasing, right? Now that's decreasing, but is it concave up or down?
Because it's facing down.
Correct. It's concave down, but it's decreasing. So how could we draw one that is decreasing, but concave up? Who can put one on the board for me? How do you check for concavity? Concavity is the second derivative. All right? So if you have a function that is twice differentiable, that means you can take a derivative twice. Right? If y double prime is positive, it's concave up. If y double prime is negative, it's concave down. All right? So whereas f prime, positive, negative is increasing, decreasing, f double prime, positive, negative is concave up, concave down. Okay? All right. So let's use the concavity test here to determine where it's concave up and where it's concave down. All right. So the domain, again, is negative to positive infinity. All right, y prime is negative 4x cubed plus 12x squared minus 4. Y double prime, negative 12x plus 24x. Is that right? X squared plus 24x. Right, let's factor, okay, so it's going to be set equal to 0. So 0 equals, and let's factor out a negative 12x. So I get x minus 2, right? So x is 0, x is 2. Now, well, from negative 12x. So 0 and 2. Now, what did we set equal to 0 to get this? Y double prime. So here we don't put f prime or y prime. We put y double prime. Well, it's just proper to do y if you're given y in the beginning. Okay? So now we're going to plug these things into y double prime and see if we're going to get positive or negative. So if we plug in negative 1, we get negative, positive, like something between 0 and 2. Let's say 1, we get positive and then negative. So when y double prime is negative, the graph is concave down. When y double prime is positive, the graph is concave up and then concave down. Okay? So, well, in one of the intervals on which the function is concave up and down, so we say concave up from negative infinity, no, concave up, from 0 to 2, all parentheses, concave down, no. Minima or maxima goes, you can get that from y double prime, y prime. Y double prime doesn't give you that stuff. All right? That's your answer. Oh,
So if it's positive, it's concave up, and if it's negative, it's concave,
okay, now, point of inflection. Point of inflection is a point where the graph of a function has a tangent line and where the concavity changes. All right? So, take a look here. Take a look at the point 0. Did the concavity change before and after 0? Yes. It's a point of inflection. Did the concavity change before and after 2? Yes. It's a point of inflection. So it's where y double prime is 0 and where it changes concavity. If it doesn't change concavity, sorry, but it doesn't qualify as an inflection point, doesn't get invited to the parties. Okay? So, a point on the curve where y double prime changes from positive to negative or negative to positive. Okay, find all points of inflection. Let's see. Points of inflection means y double prime. So y prime, did I do that right? Y double prime will give us 24x minus 12x squared. Right, so 0 equals, and let's factor out a 12x. So I get 2 minus x. So I get x equals 0, x equals 2. Y double prime. Okay? Below, when like x equals negative 1, I get negative, positive, negative. Yes. Concave down, concave up, concave down. So they are inflection points. Okay? POI, point of inflection, as opposed to, I don't know. Yep. Okay? This is at x equals 0 and x equals 2. Now, how about the y values? Where are we going to get the y values? Plug it into y itself. So when we plug it into y itself, this is going to be 0, 0, 2, 16. Get by plugging, yep, POI into y. POI into y. All right, who wants to race me to find the derivative of e to the x squared? All right, it's Elliot and me. Let's go. What method are you going to use, Elliot?
I was going to use regular y double.
Product rule it is. Let's do it.
We're not in the race. Okay, you know what? I'm going to sit on the sidelines, Gab.
Well,
Except for the losers.
so e to the x squared plus e to the x times 2x.
I'm not going to lie, I did not beat you on that one.
No, you didn't.
Wow.
You want us to factor it, right?
Oh, she wants me to know.
We're going to factor it out.
Wait, don't you have to do it?
A word of advice, a word of friendly advice. You can take the second derivative here, but you would have to do product rule plus product rule. Not a good idea. We factor out e to the x, we get x squared plus 2x.
Could you take it on an x-e-x?
I wouldn't, because I'm gonna, if this was my final answer, then I should have. But when I'm gonna take a second derivative, just take out e to the x, so you have e to the x times an algebraic function.
You're gonna chain rule this?
So now it's product rule, u, v. This is the most fun I've had all day. So, y double prime, e to the x squared plus 2x plus e to the x 2x plus 2. Oh my. Okay, we factor out e to the x, and I get x squared plus 2x plus 2x plus 2. E to the x squared plus 4x plus 2. When you guys take Calc BC, you have to come back, and I have a very funny e to the x joke.
No, what is it?
No, it's not funny. No, you won't say it.
Say it.
In college.
We'll get it.
Have you ever heard my Ella and E joke?
Me?
Ella and E generous. That's my joke.
Oh, you said that before. I think you funny last year.
Yeah.
So,
Ellen.
0.
Generous.
Oh, you can
Ella and E
When is e to the x equal to 0? Never. So now I need to figure out where this is equal to 0. You could factor it. Too bad it doesn't factor. We do the quadratic formula.
No.
X equals negative b plus or minus the square root of b squared minus 4.
I remember it with like a negative 2.
2a. Oh my god.
Love math. Wow, this is not
Dr.
Should we
Mouse
come
and
watch it?
flashbacks.
16 minus 8 is 8 over 2. Negative 4 plus or minus 2 root 2 over 2 over 2.
Are we gonna have calculators on class?
Now, I did this entire lesson. No calculator was needed. So
But you're
Oh, we're not as
you are going to have calculators on the quiz.
That.
How many is this? How many points is this? 2. Okay, now, don't go plugging numbers into your calculator. I have -2 plus root 2, -2 minus root 2. Which one of those is the smaller? Right.
Minus one is smaller.
Okay. Now, if it'll make you feel better, this is -3.141. This is -0.586. So we plug a number like -4 into y double prime. You get positive, it's similar. You get positive, negative, positive. Concave up, down, up. We have 2 points of inflection.
And we can put this back into the original one?
Yes. So here's how we do that. The x value is -2 minus root 2. Listen, the y value is e to the -2 minus root 2. -2 minus root 2 squared. Look at what I did.
You just put it all there.
Suppose x was 1, it would be e to the 1 squared. But x is that mess, so it's e to the mess squared. E to the mess, that mess squared. It's no, there's no point.
Just the end of the problem, like the mess.
That's just the one.
Jordan, we didn't start the problem yet.
Okay, that was not a fun.
Shh. Okay, now, the next part is more conceptualizing, extremely fun.
Yes.
Page or the same problem?
The next page.
Wait,
Okay.
can you go back for a second? Yeah.
Okay, now, okay, we're going to use the graph. We're given f of x. Okay, so when you're given these graphs, it's very, very important for you to see, is it f, f prime, or f double prime? So now this is f. We're going to use this where to find where f prime and f double prime are 0, positive, and negative. So first, let's take a look at f prime. F prime of x is the slope. So first, let's see where f prime of x equals 0. When the slope is 0, when you have 0 slope, it's a horizontal line. So basically, that happens here and here. F prime of x is 0. F prime of x is 0. And it says to estimate. So it's at x equals -1/2. X equals +1/2. Now, where is f prime of x positive? F prime of x is the slope. Positive slope is when it's increasing, and it's increasing from -∞ to about -1/2 and 1/2 to +∞. Where is f prime of x negative? When it's decreasing, -1/2 to 1/2. Okay? So f prime of x is positive is where it's increasing, f is increasing, and then it's negative when f is decreasing. Okay, B. F double prime of x. F double prime of x. Where is f double prime of x 0? This is where you have a point of inflection, which is where it changes concavity from concave up to concave down. So you can see here this is concave down, and then it becomes concave up, right? When does that switch happen? Right in the middle. So it's at x equals 0. Yes.
So if it's one of these concave up or downs, it needs to make a whole parabola.
No, it's, you can see where like it was like right side up and now it's upside down. You can see where it changes.
Right.
Okay, so f double prime is positive. This is where it's concave up. And f double prime is negative is where it's concave down. So where is it concave up? From 0 to infinity, right? It keeps its concavity. And then it's concave down from negative infinity to 0. Oh my gosh, I am like having so much fun right now.
I don't think I'm having as much fun. I'm just a little confused.
Okay, where?
I don't know.
So f double prime is the concavity.
Okay.
Okay. So when you want f double prime positive, it's concave up.
Okay.
So you look here, where is it concave up? Here.
Right there.
From 0 to infinity. Like it starts concave up at 0. And then where is it
And
concave
negative
down?
infinity
From
to 0.
negative infinity to 0.
Bam, I get it.
Yeah, you do.
Now I'm having fun.
Right. Use the graph of the function. Okay, so look. This is f prime. So this one is actually mislabeled. Hey, everybody, this is y prime. This is y prime. This is important now. To estimate the intervals on which the function is increasing or decreasing. All right? Now, this is f prime. To go from f prime to f, what do we look for? When f prime is positive, f is increasing. When f prime is negative, f is decreasing. This is f prime. How do we know where f prime is positive? A graph is positive when it's above the x-axis. It's negative when it's below the x-axis. So take a look here. This and this are where f prime is positive. This is where f prime is negative. Okay?
So how would you write that?
So, well, let's do a number line because that's what we're used to, f prime. It changes between positive and negative at negative 3 and 3, positive 3. Below negative 3, f prime is negative, positive, other way. Positive, negative, positive. So, f is increasing when y prime is greater than 0. So that's negative infinity to negative 3. 3 to infinity. Decreasing when y prime is less than 0. Negative 3 to 3. What else is this pesky problem asking us? Estimate the coordinates of the local extreme values. Where does this change between positive and negative? Right. So there is a max at negative 3. There is a min at x equals 3. Okay? Oh my gosh, it's 3:15 and this homework is due tomorrow.